We discussed question 6 of A-Level Pure Mathematics 3, paper 3, for May and June of year 2020. You're given a diagram whereby you have a circle with a center O, and the tangents to the circle at A and B meet at point T here. Angle AOB is given by 2x radian. So the angle is in radian. The shaded region is bounded by the tangents AT and BT and a minor arc AB. The area of the shaded region, this is what is important here. The area of the shaded region is equal to the area of the circle. Part A, you need to show that x satisfies the equation tangent x equals pi plus x. The area of the shaded region equals the area of the circle. This is what we need to show the equation in part A. Now to find the area of the shaded region, this area here the area of this shaded region. This is given by the area of the quadrilateral AOBT, this entire part, minus the area of the minor sector here. So you need to subtract the area of the sector of the circle, so AOB. We need to find the entire area, AOBT, and then we subtract the area of the sector, AOB. Now let's look at AOBT. You can actually divide this area into two right angle triangles. So when we divide this into two right angle triangles here, this angle is x, so the entire angle AOB is 2x, then AOT is just angle x here. Then the area of AOBT, this is actually twice the area of triangle AOT. Since you divide this quadrilateral into two equal parts, so you have twice the area of AOT. To find the area of AOT, AOT is a right triangle with a base of R, and the height is given by AT. Now look at this right triangle here. From the right triangle, you see that tangent x is given by the opposite over the adjacent. The opposite is AT. Adjacent is the radius of the circle, so that AT is R tangent x. And AT is the height of the triangle AOT. Then to find the area of triangle AOT, you have half of base times height, and height here is given by R tangent x. So the area of AOBT is given by R squared tangent x. That 2 and 2 can be cancelled off. The area of a sector of a circle, that is always given by half R squared theta. So you have half R squared. The angle here is 2x. So we have half R squared 2x. The 2 and 2 can be cancelled off. We have R squared x. So we have R squared tangent x minus R squared x. That is the area of the shaded region. And we are given that the area of the shaded region equals to the area of the circle. So that r squared tangent x minus r squared x, this must be the same as the area of the circle. And since the circle has radius r, the area is given by pi r squared. R squared can be eliminated. Since r is the radius and it is a positive value, we can divide throughout by r squared. Tangent x minus x equals pi. And we can move minus x over to the right side. You add an x throughout. We have tangent x equals pi plus x. That is what we have for part A. For part B, you need to show that this equation, tangent x equals x plus pi x, has a root in the interval from 1 and 1.4. So you need to show that the root lies between 1 and 1.4. In order to do that, for part B here, we know that tangent x equals pi plus x, and we need to show that there is a root between 1 and 1.4. That is what we must show. What we can do is we can just move everything over to the left. We rearrange this equation so that tangent x minus pi minus x here equals 0. Now, tangent x minus pi minus x equals 0, then we can set this to be fx. So that fx now is tangent x minus pi minus x. What we need to show is that fx has a 0 in the interval from 1 to 1.4. We need to find the value of f at 1. That is tangent 1 minus pi minus 1. Make sure that your calculator is in radian mode, and we see that f at 1 is negative 2.58. This is less than 0. Then we evaluate f at 1.4, so that tangent 1.4 minus pi minus 1. Use the radian mode in your calculator again, and we have a value of 1.26, which is greater than 0. So f at 1 is negative, f at 1.4 is positive. We can say that f at 1 is less than f at x, which is less than f at 1.6, meaning that there must be fx must have a 0 in between 1 and 1.6. So this is 1.4. So we see that the root of fx must be in between 1 and 1.4, because f of 1 is negative and f of 1.4 is positive. That is part B. For part C, you need to use the iterative formula to determine the root correct to 2 decimal places. And the result of each iteration must be to 4 decimal places. You are given an iterative formula, x sub n plus 1. This is given by arctangent of pi plus x. Your calculator must be in radian mode. So for this case, we must start with an estimation. We know that the root is in between 1 and 1.4. The x naught that we use could either be 1 or 1.4. Now look at the fx value. 1.26 is closer to 0 than negative 2.58. So we are going to let x naught to be 1.4. Your result will converge much faster. Then replace x0 into the iterative formula. When n is 0, you see that x sub 1 is given by arctangent of pi plus 1.4, and that has a value of 1.3541. This must be reported to 4 decimal places. Then x sub 1 is 1.3541. Then we iterate again, and we have arctangent of pi. This 1.4 now is replaced with 1.3541 for the second iteration, and we get 1.3519 to 4 decimal places. Now look at these two. To 2 decimal places, they're all round to 1.35. So we say that this is the solution.